What's up guys, Shawnthebro here, and we are back for another episode of the Blueprint Only Input Buffer tutorial series. So this is part 10 of the series, and specifically in today's episode we are going to be going over changing our input buffer to be a circular array, or a circular input buffer. A circular array is an array that has a certain number of elements in it, such as 60 for 60 frames in a second, and every 60 elements it starts back at 0. So instead of infinitely increasing the number of elements in the array or removing them after a certain period of time from the array, we can reuse the same allocated memory and just keep replacing the information. As far as functionality goes, you're basically just going to be able to do everything you've already been able to do, however, in a much better way. This will allow us to truly go through the input buffer how we expect to and how fighting games do. So, quick demonstration. If I press my two inputs to do my first command, I perform that command. If I perform the inputs for the second command, I'll perform that command. Don't worry about the actual animation, just look at the top left where the print strings are occurring. I can also show you the output log. So here's command 1, command 2, command 4 is by pressing this button. Releasing this button after a given number of frames is command 3. Lastly is command 5. And command 4 has the same input as one of the inputs in command 5, so they both triggered. So essentially, after this episode, you will be able to perform press inputs, release inputs, charge inputs, and multi-button commands, all using the system that we already have, except converted to a circular array. Now, for those of you that want to get caught up in the series, I'll link this playlist right here in the top right corner. You can check out all the Blueprint Only episodes, and you can see how we got to this point in the mini-series. Additionally, if you care about the other things you see in this episode, such as the movement of the character, the health bars on the enemies, the actual equipment on the ground and being able to pick it up and utilize it, you'll want to check out this playlist right here, which is the playlist for the third-person and action RPG tutorial series. Otherwise, let's go ahead and get started. So, as usual, this is the Blueprint Only Input Buffer tutorial series, so even though it is modeled after our fighting game one, it's Blueprint Only. So we only need the blueprints today. We don't have to go into the code, of course. So let's go to our blueprints, and I'm going to go to my base character BP. We're going to do all of our logic in here today. Now I'm going to give you a quick reminder of what's in my command list. First command is my two special inputs, both a press, so just pressing these two inputs within the given number of frames, which is going to be 15 after this episode is complete. Command 2 is going to be forward, left, and jump, so pressing directional inputs as well as an actual input action. Command 3 is just releasing the attack button after 100 frames of charge, so basically holding it for 100 frames. Command 4 is just pressing the attack button, so it's a single button, but it has the ability to be held for 300 frames before it automatically executes the remainder of the command, which is the release section. And lastly, command 5 is a multi-button or multi-input command where we have to press two buttons at the same time, and releasing one will void the attack. So pressing attack and my one special move at the same time within 2 frames of each other will trigger the multi-input command. Everything else in here is the same as you have been used to. Nothing else has changed. So we can go on with the actual logic in the graph. So getting started in this event graph here, let's go to our event BP tick. Now again, I am doing this Blueprint Only Input Buffer tutorial series within my third person and action RPG tutorial series, but they are completely separate. You could use this with any project that you want. So I am creating this BP tick because I have a code tick for my third person series. So I made a BP tick, and this is where I had done all of my tick logic to this point. The main benefit of this system is being able to press multiple inputs on a given frame and check against those values. So if we want to access any frame at any point, we can check all the inputs that were pressed, the states that were held, and really whatever we need to about our input. Having this array that is constantly there, the size doesn't change, so we can always access the correct element based on the tick that we're on. So in our blueprint tick, we were just basically keeping cur tick, which is current tick, at a value between 0 and 59. 0 to 59 is 60 different values. And so that is, assuming we were playing at 60 frames per second, those are all of our possibilities for 1 second. We were actually already doing this from before this episode, but it's going to come into play a lot today. Now this next part I've added. Everything else after this function is something that has already existed in the series and is shown in other episodes in the blueprint-only input buffer tutorial series. This is all for our charge information and our multi-input commands. This, however, what I've added right here, is new. It has not been in the series, and that is what we want to add today. This is the only thing we have to add to tick, is what's highlighted right here. So now we need to start keeping track of whether or not we've captured input every frame, because it's not just about when we've pressed inputs and when those inputs should be destroyed anymore. It's just keeping track of the entire frame history. So however long we decide to go, which I'm going to go 60 frames, store 60 frames of data. That way we can access those frames at any point and the data within them, the data that was pressed on them or released on them or whatever it may be. Our goal here is to be able to track 60 frames of data. I'm choosing 60 again because there's 60 frames in a second, assuming we're running at 60 FPS. And so that is a good amount of frames. It'll do everything we need, but also it's not too much. You don't want to make too many, then you're tracking too much data. Because of this, it's very possible that the majority of those frames aren't going to have input pressed on them, but we still want to keep track of that and say, nope, no input was captured this frame. Because if input was captured on a given frame, we want to set the array element of the input buffer at that current tick value, or at that frame value. So if we're on frame 30 and we pressed attack, then on frame 30 we want to store the input state attack. If we haven't captured a frame on that input, then we still want to have an f input info structure for that frame, for that value in the input buffer. Except it's just going to be a default value. So let me show you what this looks like. If we come into the game, and I go into my base character BP, and we go into the input buffer. Now the input buffer already has 60 array elements. Everything's 0 right now because I haven't pressed anything. So if you open up any of these, they're just the default f input info structure, which is what input buffer, the variable, is a type of. Input buffer is an array of f input infos. If I just start mashing buttons in here, you'll see that at some point I will happen to hit an input on index 0 of the input buffer right there. And so it has the timestamp, it has the status of what happened, and then eventually it gets cleared out and reset. But notice how for a second or so, this information was stored. Up to 60 frames later than that, this information was valid before it was removed. When we press 1 on a given frame of a second, say this is the 0 index of that second. So really, this is the 0 frame, but it's the first frame that we're capturing for that second. As I manage to press a button at that point, this information gets filled out. Then if we come around again 1 second later and I haven't pressed any input on this frame of that second, this is going to be erased and just filled out with none. Going back into our base character BP now, this is what we need to do. We need to make sure that if we haven't captured input on this frame, that we make a default input info structure that we can use to pass to the input buffer at that tick or at that frame for the second. Otherwise, if we have captured input for the frame, then we just want to say we haven't captured it for the next frame. This frame's already done at this point because we're on tick. So for the next frame, we want to reset this value back to false, saying nope, we haven't captured input just yet. For those of you that have watched the fighting game tutorial series, you may know that the captured input this frame is also used for when multiple inputs are pressed on the same frame. And that will be our final topic of the blueprint-only input buffer tutorial series. We will then have an episode on enhanced input so that we can get everything working that we have in this series in the enhanced input system. To get started on this logic right here, we want to make a new variable called captured input this frame, and that's what we're going to use for this section. So we can just make a new variable by pressing the plus here like we always do. And I'm calling it captured input this frame. Boolean as the type. And right now, even though we haven't set it, we can go ahead and set up the tick logic because fundamentally we understand what's going on. So it doesn't matter if the value is actually there right now or not. We will set it up to be that way in just a few minutes. So we can get our new Boolean and we can check not bool. So basically, we want this to be false. If we haven't captured input this frame, that's when we're going to make the default structure. So if we bring this into a branch, the branch's true is really saying that we haven't captured input this frame. So that's what we're trying to do now. We are trying to create the default input to pass to every frame where a player did not press the input. In my case, it's going to be make f input info because f input info is the name of my structure. The node is going to come out with all the default values filled out. That's all we need. We don't have to set anything. We want the default values because this is an empty structure. The player hasn't pressed anything on this frame. That's what I have here. Now, our input buffer, we can get that, and we can drag off of it and type set array elem, which is for set array element. You need to pass it an index and the item you're adding at that index. For the index, we can use our cur tick, which is our current frame for that second. Because at that frame of that second, we want to place this object. For the item, you pass in the make f input info return value. You don't have to say size to fit here. This will change the size of the array to make sure this element can be added. If our logic is set up correctly and we are actually using a circular array, or the size of the array won't ever change. It's not required to check that, and it's a little bit faster if we have it disabled. So I'd recommend leaving it off. Now, for the other case, the case saying that we have captured input this frame, so if not captured this frame returns false, that means we have captured input this frame. That means we just want to reset our captured input this frame Boolean back to false. That way we can go start our next frame for that second with a clean slate. We're saying we no longer have captured input for the frame. We're resetting our value. That way we can start back at the same state we started our last frame. Kind of a mouthful. So essentially what we need to do here is just reset our value back to its default, which is false. So you can just set captured input this frame to false. Regardless of what the branch takes, if it's the true or the false, they're going to meet up and they're going to lead to the rest of the logic that we had in the blueprint tick. This is all we need for the blueprint tick function or the event, so we're good with that. Now our input buffer will be filled out every frame with that correct data, or it would be if our input buffer had any data in it. By default, our input buffer actually did not have any data. What I've done now is added 60 blank elements. Because again, we're not trying to resize this array anymore. So by default, by clicking on the input buffer, going to the details panel, default value, you can press the plus here to add elements to the array. I would add 60 elements. That is 0 to 59. They're all empty right now, but don't worry, when we go into our add input to input buffer function, then we're going to fill these out at the frame that a player pressed an input with the input data that they actually entered. So the next thing we have to do is go down to our perform input logic function. Perform input logic is called from any of the input actions based on if it's a pressed or a released with the key that was pressed to get us there. We set this up in an earlier episode, so I'm not going to go over it. But in this perform input logic, we were checking to see if it was pressed or released, and then we were removing any old inputs from the buffer. Remember, remove old inputs from buffer, went through, determined how many frames apart these inputs could be, added them to an array to remove them, and once we were done iterating through the array, we removed the values that we had to. But again, we're not doing that anymore. So you have a few options here. You could leave pressed and release plugged into where they were and disconnect the node here. So that remove old inputs from buffer just didn't do anything. Additionally, you could do what I was doing there in the demo, which was to just bypass these nodes, just skip the remove old inputs from buffer function calls. Or you could go as far as to just remove these function calls from here. And so now my perform input logic just looks like this. So it's actually even simpler than it was before. We're not adding anything here. We just don't need to call that remove old inputs from buffer function anymore because we're not removing them. We're just going to overwrite them every frame. So if nothing was pressed, then we don't utilize it. If something was pressed, then we're checking against it to see if we can perform a command. You could go as far as to remove this function entirely, but I'm not going to do that. I'm going to keep it. I like to keep my old logic as far as these tutorials go. That way I can always reference them and assist people. So I'm keeping mine, but if you would like to get rid of yours, you can. Or keep it in case you want to do anything with it in the future. It really is up to you. Anyway, once we're done with this, now our basic event graph is complete. We don't have to make any other changes in here. Add input to input buffer. Now we call this function within the perform input logic event here. We pass the data along that we want to be added to the input buffer. Let's go into that function now. In here, it's a little ugly, but we're going to clean it up, of course. So what we were doing before was just literally calling input buffer add and passing in the f input info structure into this input buffer. And we were just adding it wherever. It's a little bit different now because before we do that, we want to make sure that we add it to the actual index that we care about. Since we're doing it, again, off of a static array size, we want to make sure that we're adding the input that was pressed at the correct frame. So we're not just calling input buffer add anymore. Instead, we're going to call input buffer set array elem and pass in the current tick. So you can remove your add node here. And I'm going to space this out a little bit. The check input buffer for command we're still going to want, but I'm just moving it over so we can fit everything in here. And now it's going to look like this. Input buffer set array elem like this with cur tick as the elem. And something like that will do. Again, size to fit doesn't have to be checked. But one thing we should do is set our captured input this frame to be true. So we updated the add to be set array elem, but we've also added a new node entirely, which is this one here. And we're setting captured input this frame to be true because we have. We've captured input at this point. Input has been pressed and we've recognized it or released. Whether it's been pressed or released doesn't matter. Just an input has been found and we want to make sure that we know about it so that we don't override this input with a none input on the tick. I still call check input buffer for command at the very end of this function. So make sure you still plug that in. And we're good to go with add input to input buffer. Now check input buffer for command is the last function that we need to take care of, but it is very busy and very ugly. So we're going to clean it up as we always do. Okay, I know this is going to look crazy, but I'm going to go over every single part of this. Most of it hasn't changed. It's just that I have a few extra nodes that I've placed up and out of the way, which happen to make this really ugly right now. But we're going to work through it together. Because this is building on 9 other episodes all for this one topic, I'm going to go over the whole thing in this episode. That way we're all on the same page. So when we get into check input buffer for command, we're doing exactly what the function says. We're looking to see if the inputs the player has pressed matches any of the commands. To do this, we were going through all of our commands because we want to see if any of them meet the requirements. We were then setting correct sequence counter to be 0, our default value. The problem with that is correct sequence counter shouldn't be 0 anymore. Correct sequence counter was used to determine how many inputs we've gotten correct while checking to see if we perform this command. So for example, if backward, forward, light attack was our command inputs and we performed backward and forward, our correct sequence counter would have gone from 0 to 1 and then 1 to 2. It still has to get one more correct input before we can perform the command. However, we are actually going to loop through our input buffer backward now, because we can't just assume because there's elements in front of our input that we're checking that we want to check it. The input buffer now always has a size of 60. Remember that. So we don't want to check all 60 frames every time an input has been pressed. Most likely you have to enter your inputs within 2, 10, something a lot smaller than 60 frames to actually perform the command. Say we have 4 frames of leniency before backward-forward light attack. Well, we only want to check the last 4 frames of data, not all 60 frames. So we're going to check our correct sequence counter backward. So basically, if we meet the last input in the input buffer, say yes, we've executed that one, we know we are eligible to perform the command if the previous inputs match it. Otherwise, the command just might not be finished by the player yet, in which case we want to skip it. So, from now on, our correct sequence counter is not going to be set to 0 when we make a mistake, but it's actually going to be reset to the number of inputs in the command. So, in the case of backward-forward light attack, that example I was using, there are 3 inputs in the command. So the correct sequence counter is going to be 2, and once we reach -1, then we'll know we have performed all the successful inputs in the command. It might be a little confusing now, but that's okay. Let's start using it, and it should make more sense. So the loop body for the command list was going into the set correct sequence counter 0, but I'm not doing that anymore. Instead, I'm setting it to the length of the inputs array from the F command info that we got from the command list at the index we're looping through. Okay, so all of this was already here. Just literally, instead of setting correct sequence counter to 0, we're now going to take the inputs array off of the broken F command info we have, and we're going to get length. Then off that length, we're going to subtract 1 from it because, as always, length refers to the actual number of elements in an array, but the array indices, they start at 0. So if I have 3 inputs in my command, I actually have 0, 1, and 2. Those are the indices. So I have to do length minus 1 to get the highest index of the input in that command. Then drag off that and set correct sequence counter to this value. If you want to put it in now, you can. So for me, I'm going to get rid of my correct sequence counter being 0, and I'm going to fit in these 3 nodes. Okay, now this doesn't look too bad, but it's still very ugly with all these lines, so let's see what we're doing here that we can either change or get rid of. So the next thing we were doing was taking our inputs array, the one that we just plugged in to get the length, and we were plugging that into a for each loop and looping through all of the elements in this array. We actually don't have to do that anymore. The reason we were doing that is because we wanted to loop through each individual input, and we were breaking that to get the type status required charge frames and the is currently held boolean. This is no longer necessary. If we do this, actually, we'll be looping way more times than we need to. We're going to use a new method of determining what elements from the command we should be checking against, and that is something called our max frame between inputs. We actually set up the max frames between inputs variable in a previous episode, and this is how many inputs we want to have between these frames on our command before we can no longer execute that action. 15 frames is how many frames apart I can press my inputs for that command and it still triggers. So for example, if I want to press them, if I press one this frame and another this frame, that's too far apart. I won't trigger the command. However, if I press one a little bit faster, I do trigger the command. If I press it really fast, of course I trigger the command. Before, that was based on if it was removed from the input buffer or not. But we don't need to do that anymore. We can just check against the actual number of frames back that we can still perform this command. So if I can only perform this command 2 frames apart, so if I change the max frames between inputs to 2, this window becomes a lot tighter for me to actually execute this command. So now I can press it pretty fast and not trigger it. Now if I press them right next to each other like that, I can of course trigger it. So this value represents how many frames apart they can be pressed and we can still execute it. We only want to check those elements within the input buffer for this command input. So instead of using the array element for this break, we can actually get the value of this array at the correct sequence counter. Instead of getting this for each loop and passing the array element into the F command input, we can just pass in the get into this break. So quite literally, you can drag off the inputs array, type get. A reference will be good for us here because our multi-input commands can change values on the actual command input right here. And so we're going to make sure we have a reference, not a copy when possible. So get a ref, and then pass this into the break that is already here. That's what I've done right here. And for the index, you're getting the index at correct sequence counter. The end result is this right here. I'm going to straighten the connection to the get. And there we go. We can remove that other for loop. This is going to increase our performance by quite a lot. Now we have one other section up here as well that we have to fit in. Since our input buffer is that constant 60 size now, we only want to check the number of frames between inputs, because if we go outside of that range, we know that we can't perform the command anyway, even if the player pressed the correct inputs. We are going to use our max frames between inputs and plug that into the last index of a for loop up here. So max frames between inputs goes into this for loop. So this is a standard for loop. And max frames between inputs is going into the last index. What we're doing in this section is making sure that the frame that we're checking falls within the boundaries of the input buffer. This is definitely a paint scenario, so let's open up paint. Let's just use letters here because it'll make sense. So say we had inputs A, B, and C. You can think of what they correspond to, such as backward, forward, light attack, or you can just think of them as literal keys on the keyboard, A, B, and C keys. Now say we had a command number 1, and it was AC. That was how you executed that command. You had to press A and C. Well, in this case, the input buffer would just check to see if A was at a certain part in the input buffer. It wasn't interrupted by any other inputs, and then C was pressed before A was removed from the input buffer. And then you would perform the command. That was super simple. Nothing complicated about that. However, like I said, the circular input buffer is much better for a lot of the stuff that we're going to be doing. And so we want to make sure that we can do that and utilize that correctly. But the way we're checking that is going to be a little bit different, because we don't want to check all 60 frames every time we want to see if A and C were pressed without an interruption. Instead, what we want to do to make this significantly more efficient is take the index that we're using. So this is a for loop of 0 to 15 for my first command, because max frames between inputs for my first command is 15. So 0 to 15. We want to take the current tick. Let's say we're on cur tick 30, which is half a second in, right? 60 FPS. We're at 30. Technically, that's the 31st element because of index 0, but let's just use 30 as it's an easier number to work with than 29. Now, we want to subtract the index in the loop that we're at. So we're going to start at 0 because first index is 0. So we're going to do 30 minus 0. So we have the input buffer, the length. We know the length of the input buffer is going to be 60. So we want to say 30 minus 0, and that's 30. Then we want to plus the length. So len of our input buffer, which is going to be IB, and that's going to evaluate to 60. So 30 plus 60 is 90. So 90 is the current value that we want to check in our input buffer. But that doesn't really make sense, does it? There's only 60 elements in our array, so how could we have 90? Well, we can't. But what we can do is use modulus to get our value of 90 to be representative of where it would actually be within our input buffer. So some of you may not have seen this before. Modulus is the percent sign, and you can find it by literally typing the percent sign, and it'll be mod integer, or modulus like this, and you will get mod integer either way. You're going to take the result of the addition here and mod it by the length of the input buffer. So 90 mod 60. Now modulus, what it does is it's going to divide this number by this number, so 90 divided by 60, but it's going to actually return the remainder. 90 divided by 60, if we get the actual number, it's going to be 1.5, but let's do it on a calculator so you can see it. 90 divided by 60 is 1.5. Now, the remainder of this is 30. There are 30 left over. In this case, it's easy to figure out the remainder because basically you know that 60 only goes into 90 one time. 60 times 2 is 120, which is greater than 90. So it only goes into it one time. So you can literally do 90 minus 60 to get 30. That's your remainder. That's what modulus returns. So in this case, modulus is going to tell us we should check frame 30. If our cur tick is 30, the very first frame we should check in the input buffer is 30. But that's what all this is saying. Let's use a different example. Let's use the next element in a for loop, which would be 1. We just did 0. Let's do 1. So let me erase this. And I'm actually going to put another piece of text here. And let's say cur tick. And we're going to say that that is 30. We can still use 30 as the cur tick because we're all doing this on the same tick. But now let's look at this again, all right? So we have cur tick, which is 30. 30. Then we're going to subtract the index. We already did 0, so we're doing 1. So 30 minus 1. That's going to equal 29. All right. Now, 29 plus the length of the input buffer. We know the length of the input buffer is 60. So 29 plus 60. And we'll get 89. Last time we got 90, this time we're getting 89. Now, we're going to do 89 mod 60. We're doing the mod the length of the input buffer again. 89 mod 60. Now, I can tell you right now it's going to be less than 1.5 because 90 was 1.5 and we're starting with a smaller number, but dividing by the same. So let's do 89 divided by 60. Now it's 1.48333. It doesn't matter what that value actually is. Remember, it's the remainder. 89 minus 60. 60 goes into 89 one time with a remainder of 29 left over. So we can say equals 29. Now you may have noticed that we keep getting the same number here. So whenever we do the cur tick minus the index, we get a value. At the end, it always seems that we end up with the same value. And for the most part, that is actually true. You could see, yes, we're getting the same value. Why are we doing these addition and this modulus? So let's take some of this out. Let's say cur tick is actually 0. Say we're on the first frame of this new second. And let's run through this again now. So let's say we have cur tick, which is 0. Minus, and let's say we're on frame 13 of this for loop. 0 minus 13 equals negative 13. Well, negative 13 is not going to be a valid index in our array, but it should still relate to a value within our input buffer. So what we can do now is continue along, and we can instead add the length of the input buffer, which as always is 60. And from that, we will get a positive 47. Now that is an index in our input buffer, and it makes sense too, because if we are to go from 0 and subtract 13, then we would get to index 47. After reaching the beginning, if we start back at the end and take 13 units, we would go back to unit 47. So if we do mod 47 by 60, the remainder we get is going to be 47. 47 can't be divided evenly by 60, so we get the whole remainder of 47. So it's still valid with the modulus. All right, at this point, we have our frame to check logic. So now we just have to implement it if you haven't already. Our for loop with our last index comes out and we take curd tick minus the index. From here, we add the length of the input buffer. Then we perform modulus from the addition result and the length of the input buffer. This value we're setting, frame to check, you might not have. That's another local variable that I made. So correct sequence counter is a local variable. It's only available in this function. This frame to check we only need right here, so we also only need it available in this function. I simply made a new local variable that was an integer that I called frame to check and set it here. This is the only place that I set it. It is 0 by default, and it will be updated every loop iteration so that we know what frame we need to look at next. From there, we can actually get the data of that frame because we have this frame history now. Now we can go ahead and plug this in and actually put this where we want it. So I'll clean things up again. You can move it with me while I do it. We don't have all this stuff floating up above. So let's organize something. This max frames between inputs, we weren't using it before, so we never had any reroute nodes. Let's go ahead and address that. This will look a lot nicer. And then additionally, just make sure that nothing is overlapping here where you can't see it. We look pretty good. There's one other node here that we're going to want to clean up, but we haven't gotten to that point yet. So now, after getting the frame to check and getting the value from the array of the input buffer based on that frame to check, we can continue. So make sure you drag off your input buffer, type get. This time it can just be a copy because we don't set anything. We don't actually change any of the values of this one that we grab. We're just checking against it. It's already history. It's not the current frame. It's not the current data for the frame. It's just a check that we're doing to grab the data that was on that specific frame. We don't need a reference. We can just use a copy, which will be quicker in this case. Make sure after getting the frame to check, you plug it into the for loop that was already here, the for each loop with break. And this is the main for loop where we actually do the checks for each of our inputs in the input buffer against the inputs within the command. You'll know this is the correct one because there will be an execution line, which is the white line here coming from start command, wherever else. It has a few points actually. And it comes all the way back into this for loop and goes into the break. Once they're connected, we were checking to see if our correct sequence counter was less than the maximum. That way we knew it was a valid index. We still want to do that, but doing it this way won't work anymore because remember what we just talked about with the frame to check? We're now reversing the way we're going through the input buffer. So instead of going from 0 to the maximum, we're going from whatever index we're at and decreasing. So just checking by addition won't work anymore. Instead, what we need to make sure is that correct sequence counter is greater than -1. If it's greater than -1, we know that we haven't found a command yet and we can continue to loop. Now the correct sequence counter addition, the new result essentially for the correct sequence counter, was being plugged in to get a value at the input buffer, but that is also being replaced. You can see mine is actually not connected anymore. The get that we just got off of our frame to check is actually what's going to be plugged in here. To the next break input info right before the is input and multi-input command. You don't have to plug it in right now if you don't want. We can do it when we get to that point, but just know you can get rid of this correct sequence counter plus less than and the input buffer length. You can additionally get rid of the input buffer get here. Check to see if the correct sequence counter is greater than -1. There we go. So the F input info that we're actually using to check against if the input is pressed, if it's released, or if it's a press when it was a hold, that is now coming from this frame to check get and not the input buffer get at the index. Now we're not using anything from this actual input buffer loop here as far as the element or index go, but we still need to make sure we loop through every single input buffer element because we do need to make sure that what the player has pressed is being taken into account. We have our balance check here with our correct sequence counter. We have one other check here as well that I've added that wasn't here before. So previously the balance check led directly into the is input and multi-input command if it was found to be true. But now we also want to make sure that the F input info here that we're using for all of our checks is not equal to none. If it is equal to none, we want to just skip it. We don't want to do anything with it. Remember that a lot of our inputs in our input buffer will be none because on tick, that should not mean that the player is penalized because they obviously cannot press 60 frames per second accurately. They're not a machine. So we want to just leave it alone. We want to actually skip it. To get this node, by the way, you just drag off the F input info and type not equal or exclamation mark equal and enum, and then just leave it at none, and then bring this into a branch. Only if it's true from here will we go into the is input and multi-input command. Otherwise, we'll just leave this logic alone. There's one other step here that we need to do, and that is if the correct sequence counter bounce check fails, we had a false. The false was resetting the correct sequence counter back to 0, but of course we don't want to do that anymore. We now want to set it to the length of the input types array. So just like we did at the start here, where we had the length of the input types array -1 and setting the correct sequence counter to that, I have a reroute node for my inputs array right here, and if we follow it, I use that to get my length -1 and set that to the correct sequence counter. It's no longer being set to 0, so I'm getting rid of the 0 and I'm setting it to this instead. Now the rest of this is the same until we get over to the next part where we set the correct sequence counter back to 0. This time we were setting the correct sequence counter back to 0 because the player had pressed an input that was incorrect for the command, which led us to this false branch. And then it turned out that it was not the released status, meaning it was a press or a hold. Either way, this means the player pressed the wrong input to perform this command, in which case we were setting it back to 0. But of course, we don't want to set it back to just 0 anymore. Instead, we're going to set it back to our length -1. So put this in here, and we will clean this up. Just like that. Now, for the length, it's pretty obvious where it's coming from at this point, but notice this is the same array from the F command info at the very start of the function. We're using this inputs array. So if you follow my line, that's what is plugged into the length here. Just bring it up some way where it looks relatively neat. Following down the other branches here, we were checking to see if this was a chargeable command or a multi-input command. If it was a multi-input command and we had found that we released it, we were setting the correct sequence counter to 0. And one final time, we have to do what you'd expect. And instead of setting it to 0, we set it to the length -1 and use that instead. So I'm getting rid of the correct sequence counter being 0. We actually already had the length here, as you can see. I was already using the length here because previously we were checking to see if the correct sequence counter +1 was equal to the length of the command input array. So I'm using that same length here, subtracting 1 from it, and setting the correct sequence counter. It would look something like this, assuming I actually put it where it was supposed to be. And then I just brought that into the same logic that we had before. So essentially everywhere set correct sequence counter was 0. We're just setting it to the length of the inputs array from the F command info structure -1 and setting that to correct sequence counter. Now last thing we need to do is here. So assuming this first branch that we had after the first is input and multi-input command check is true, that is when we were increasing the value of the correct sequence counter. But remember, we're now trying to go in the other order. So instead of going from correct sequence counter of 0 to 1, if we're on 1, we should go down to 0 instead. We're actually trying to reach -1 with our correct sequence counter right now. That's how we know we've matched the number of elements in the sequence. So where we had correct sequence counter increment equals the length, we don't need to do that anymore. We can get rid of that. Instead, we want to do this right here, which is correct sequence counter minus or decrement int equals -1. And if that's true, that's when we call start command. If it's false, we bring it up here, and it goes into the break just like it always has. Then here at the very end, we were calling start command, which was triggering the actual command. Nothing has changed in here, so this is all the same. Then we were clearing the input buffer, and we were setting the correct sequence counter back to 0. We actually don't have to reset the correct sequence counter anymore with the new method that we're using. And we don't have to clear the input buffer anymore either, because the input buffer is now going to be the same size. It's going to be 60 elements the whole way around. So I'm going to get rid of these two nodes, and I'm going to make sure start command does go into the reroute node that goes to break the for loop that I mentioned earlier. So make sure that's still happening. All right, guys, time for the final recap because this was a very long episode. So we're going to go into check input buffer for command, in which case we're going to check to see in each command if the elements of the command actually match what is in the input buffer. To do this, we set the correct sequence counter up to the maximum number of elements in the inputs array. We get the data from the command, such as the type, status, and required charge frames. Then we determine what frame we're currently at for this second, and that will allow us to determine what frame to check based on how many frames these buttons can be pressed apart and still be considered a successful command press. By checking that element in the input buffer, we can then make sure that we are in the bounds of the command, so we haven't gone past the correct number of inputs somehow, or more importantly, that we haven't met the actual requirements to perform the command, thus we should still keep searching. If that is the case, we want to go and make sure that it is not equal to none, because if it is equal to none, we don't want to count it against the player. Most likely they just didn't press any input that frame, and that's not an issue. It's still a valid frame. It's still useful to know that they didn't press anything on that frame. Then we do all of our standard checks that we covered in other episodes. So for how we want to perform every single command and command type that we have. And then if we get a correct press, we decrement the correct sequence counter. And if it is equal to -1, we know we have now reached the part where we've pressed all the correct inputs to perform that command. So we should start command. One final note here is about this for each loop with the input buffer. I mentioned earlier in the episode that we wanted to keep it to loop through the elements in the input buffer, but I've since realized that we actually don't need to do that at all because we will have the direct element from the command that we are checking against right here. It is now coming from our frame to check variable. So we can actually remove this for loop entirely since we aren't using anything about it, and we don't even need to do the break anymore either. Technically, you'll get the same result whether you have it in here or not. I'd get rid of both of these after disconnecting it. And then I'd also get rid of the reroute nodes that went from the ending of any of the paths into the break section of the for each loop with break. Anyway, guys, that's all I got for today, so thank you so much for watching. I really hope you enjoyed, and if you did, please subscribe. That's more for myself and the channel than anything else you can do, and I just really appreciate it. I want to give a huge shout out to my YouTube membership and Patreon members and supporters. Thank you guys for all the love, and for all the support you do give. Glad you're enjoying the series. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. It's completely free. And anyway, guys, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.